Astronauts to the moon.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
However, it can be easily demonstrated that these assumptions are merely descriptions to fit the narrative that we are on a spinning ball Earth, when in fact all of these observations can be made over a flat surface across a very short distance, which is what we'll see here, looking along this road on top of a dam. This is a straight stretch of road across the top of the dam, and then the road goes around the reservoir. Looking at it from Google Earth, I measured the distance from where I was stood with the camera to where it starts to turn off around the rest of the lake, and we got 650 meters, so just over half a kilometer, not very far at all. So by putting the camera on the ground, we get a similar perspective to that of someone standing on the shore watching a ship go off into the distance across the sea. Keeping in mind that while any surface in nature can be flat, it will always be rugged and never completely smooth like an artificial surface. So first off, we can see this optical phenomenon going on with the railings, which is exactly the same as what is seen in photographs of the causeway and the power lines going across Lake Pontchartrain in the United States, with the claim that this is proof of curvature, when in fact we can see exactly the same thing happening here with these railings. We are below the railings and they appear to bend down towards this band of convergence. The yellow line is the camera's eye level, and the camera's quite level now, so we can see that there is this band of convergence above what appears to be this horizon line of the surface. But this horizontal line is not where the surface begins to curve away from us in any way. It is just as far as we can see from this low perspective before the surface beyond it begins mirroring. This photograph of a fjord taken in cold weather shows the same optical phenomenon happening at the horizon. The purple line shows where the surface actually meets the shore on the other side of the fjord, but then we have this mirroring beneath that and going down to what appears to be the surface of the water. Even with a relatively high perspective above the ground, we soon get this mirroring and convergence. And we'll see as we bring the camera down that the apparent horizon, that hard line of the surface, will come closer to us. The lower we go, the closer the horizon over a flat surface. The surface is still there, sorry about the camera, but it is now mirroring. And as we lift the camera up again, we'll see the mirroring receding and going back into the distance. I'll bring the camera down again and we'll see the horizon come rushing towards us as the surface beyond it mirrors instead of showing us the actual surface. This is why some people will claim that there is a drop in the horizon over distances and that the surface does not appear to rise to eye level, when in fact it does, and the horizon is always at eye level at any height. However, there is this band of convergence and mirroring just below eye level. So when we look across a vast ocean or across a blanket of clouds from high above, we eventually see this convergence, but there is no background color like there is here with the trees. So we just get this transparent band, making the apparent horizon of the surface appear lower than eye level, making it appear as if there is a drop in the horizon when the surface is still there, but has just become blurred and transparent in our vanishing point. So again, as we bring the camera down, we can see here that the horizon gets closer across this flat surface, and everything beyond it becomes swallowed up in this mirroring and convergence. The railings go back to looking straight again as we gain more height, and the lampposts and the railings are now following the laws of perspective, but as we go down, the railings get swallowed up in this band. As this cyclist rides off into the distance across this flat surface, we'll see the same phenomenon that we observe with ships going off into the distance and assumed to be going down a curve, when in fact we can see that his feet and wheels are now disappearing, but he is also being mirrored by the surface. So we have the surface mirroring half of that, and the actual rider still on the surface and being observed, even though we cannot see his lower half very clearly. And as he gets further away, there'll be this kind of separation of the two, and we are left with just this top half that seems to be floating above this band of convergence or mirroring from the surface. And this, we will see in a moment, is what we actually see at sunset. We see the sun not going down below this apparent horizon of the surface, but we see first this mirroring, and then as it gets further away, it just disappears, just like the cyclist. I'm going to raise the camera, and the cyclist will pop back into view, even though he's on a flat surface. There he is. And you'll watch him go round the corner to the left in a second. So this shows that giving ourselves a little extra height over a flat surface will allow us to see a sunset twice. We don't have to be looking down the curve of a ball.